Today we are doing templates. Templates are ways of directly to the object-oriented programming language. They are not part of the object-oriented programming language techniques, but they are a way of achieving this abstraction of algorithms. We say that you design your algorithms independent of the types. Okay, we don't have a specific. Well, generally, we don't have specific algorithms for integers or for characters or for doubles, right? The sorting algorithm is a sorting algorithm. You just sort integers or doubles, doesn't matter. For example, for the bubble sort, does bubble sort work with the integers or doubles or the day of year objects? Doesn't matter what kind of object we have. We run the same algorithm, okay? So the templates are a way of achieving this. You tell as using the programming language of C++, you tell the compiler your algorithm, and you ask the compiler to produce some code for a specific type, for example, for an integer. So you specify the first algorithm for the bubble sort or the quick sort, and then you ask the compiler, okay, make it work for the integers or the doubles or that kind of stuff. That's called templates, okay? And we use this a lot, and in fact we have been using it for many cases. For example, vector is a templated class. Vector, you say that, okay, I have a vector, the algorithm for the vector is already there, okay? What is the algorithm for the vector? Algorithms for the vector: how to access the elements, how to add one element push back, how to remove one element pop back, how to return the size of it. These are all independent of the type of it, and you specify the type of the vector. Now it becomes a nice concrete vector of integers class, right? So in this chapter we are going to see how to write classes like the vector class and how to write generic code so that we can instantiate them later for specific classes. Okay, so first function templates, then class templates. Then remember we have the partially filled array, partially filled array, partially filled array D. It was an array of doubles. Now we are going to make it partially filled array for any object. Like it's going to be integers, partially filled array of doubles, partially filled array of integers or characters or day of year objects, or partially filled array of partially filled arrays, etc. Okay, so that's what we are going to do. So this is what the book says. Okay, allow very general definitions for functions and classes. Okay, the type names are parameters instead of actual types. So when I'm saying that, okay, this is my templated class, but I'm going to give you a type to instantiate it. So it's a vector of integers. Vector will specify the generic class, okay, and by providing this integer, now it is not a generic anymore. It's a vector of integers. The book doesn't say this, but it is in the slides. Precise definition determined at runtime. No, it is definitely a compile time thing. Okay, so definitely know about this. Templates are compile time things. They have nothing to do with the runtimes. Using a template structure doesn't slow your program down, doesn't make it faster. It is only it's not like polymorphism. Okay, remember with the polymorphism, given a new object, okay, you determine the exact function by looking at the object itself. This doesn't happen with the templates. Templates are decided during the compile time. During the compile time, I know this type. It is an integer, vector of integers. Okay, so precise definition determined at runtime is definitely wrong. It is compile time thing. Okay, I didn't want to fix this so that I can stress this out. The book doesn't say it this way. The slides are wrong. Okay, let's look at this example. This is a very simple function for swapping, okay, two integer values. I have two integers, variable 1 and variable 2, okay. I define a new, of course they are by reference. I define a new temporary integer, assign var1 to a temp, this one to this, and this one to this. You have a question? You have a question? Okay. This is the algorithm, right? What do we do with just, what is this? What did I do there? No, well, I think it is wrong, right? Let me do this. Control C. Yeah. Algorithm is very simple algorithm. Well, I'm sure the first time you have seen this algorithm, the swap algorithm. Okay, this is our temporary. This is our value 1. This is our value 2. What do? We put value 1 to temporary, right? Then we put value 2 to value 1, and then temporary will go to value 2. So this is step number 1, step number 2, and step number 3. So very simple algorithm. Doesn't matter what kind of values I have. It could be an integer, it could be a double, it could be a day of year, it could be a vector, it could be anything. As long as it is assignable, it should work, this algorithm. But when I write a C function, of course I talk about algorithms, but I need to talk about specific types. Okay, so this function is a nice function. Okay, I put variable 1 to temporary and etc. Just 4 lines of code. Sometimes it is confusing for new beginners, but it's a very nice function, nice written function, simple function, and we know what it does. But unfortunately, this function only works for integers, right? It doesn't work. I mean, if I like to send a double, two doubles to this function, it's not going to compile, because integer references are not double references. I mean, you could have said, let's do the pointers and etc. Well, I mean, with the pointers, it doesn't work either, because this function needs to know the size of the values that is being passed, so that it can make that many copies of bytes, right? Since integers are 4 bytes, then this means that this is a 4-byte copy, 4-byte copy, and 4-byte copy. If this is a double, then it has to be an 8-byte copy. If this is a vector, then it has to be a deep copy, right? Yes. Can't we use? No, of course not. Why? Because if you, first of all, auto is his keyword, right? You are not allowed to use that one, and you are not allowed to use auto anyway. So nobody's, what? Yeah, I don't know what's going on. I mean, that's why I don't like you much. No, you can't. Why? Because auto is determined. It's something that you determine during the compile time. When you put two auto keywords in there, right? Two auto keywords in there, you don't know which one to. Well, maybe I shouldn't be this. Can we delay your question to later? Because they made some changes to auto later in C++ 17, and it later became possible. But I'm sure they are going to give up that idea, and in C++ 27, auto will be forbidden again. For now, no. In C++ 11, they say no, we don't. But the idea is kind of the same. But we cannot generalize auto that way for all kinds of wherever the templates can happen. Auto can solve that problem. No, it doesn't happen. Okay. No, you can't. Just delay it a little bit. Okay. So what I'm saying is that, okay, I cannot call this function with any type that I like, because this is a specific function for the integers. So they said this, okay, because this for the characters I have to write it again. Well, you might say I can overload it, yeah. But I mean, there is no end to it. Instead, they came up with this idea. They said that let's write a function independent of the type. That means the algorithm itself. Okay, the algorithm itself. When you say swap values, okay. When you say swap values, I am going to swap the values of two variables, variable 1 and variable 2, okay? All I am saying is that I have a type T, and these two variables will be references of this type T. I don't know what that type T is, okay? The important thing is that I am going to run this algorithm. Algorithm is define a temporary of type T. I don't know what type T is. Then assign this variable 1 to temp. The algorithm is exactly the same. So this is not a piece of regular C or C++ function, okay? This is not a regular C or C++ function. Instead, this is a generic function that talks about an unknown type T. And template is a C++ keyword. You already know about the class, right? Class T is just class is the keyword class, but it doesn't mean much in this context, but we are going to talk about it. Just memorize this line for now as it is. You are saying that I am not specifying, I am not giving you a function definition, okay? I am not giving you a function definition here. I am giving you a template definition, okay? So template definition is not a full-fledged function, not a concrete function, but kind of an abstract function. Remember the abstract classes? Abstract classes by themselves, they don't work much, okay? You need to derive some other classes from it. Templates are kind of that too. A templated function is not a regular full concrete function, but it only specifies an algorithm independent of the type. You are saying that my function will depend on this type T, and this is my function. Then C++, by the way, the compiler doesn't produce any code when it reads this function, this template definition. Okay, it's an abstract thing for it. Okay, it doesn't produce any code because code is not producible. It doesn't know the type. It doesn't know the meaning of this assignment operator because it doesn't know the type T. Okay, it doesn't know the type T. So the first line is called the template prefix. This one is called the template prefix, and it tells the compiler that I am not writing a specific regular function. I am writing a template. That is the algorithm. Okay. So how do I use this template? How do I instantiate this template? Okay. This is called template instantiation. This is very simple. You just simply, okay, call it. Okay. So why don't I use the books example? Okay. This is my swap values template to T references, and then I am just giving the algorithm itself, and then in my main function, this is how I am going to use it. I just call it onto integers. See this one, line 23. I have two integers whose initial values are 1 and 2. Okay, I call the swap values on integers. The compiler, as soon as it reads this one, as soon as it reads that one, okay, it instantiates a new function swap values. The compiler instantiates it. Again, this is not a runtime thing. It doesn't happen during the runtime. It happens during the compile time. While I am compiling this line, okay, they say that are there any functions that take two integer references? No. Is there a template definition that I can instantiate so that it produces a template? It produces a swap value that takes two integer references, yes. Then it immediately produces a function that takes two integer references, and the function is there, and the compiler produces code to call that function. And then, of course, I print these two integers. It will be just swaps 1 and 2. Their values are swapped, and 2 and 1. And then I define two characters. Again, I call at line 30, I call the swap values function again. The compiler, again, no runtime thing. Compiler says that, okay, I am going to instantiate the swap values because all I have is a swap values function that take at this line 30. I'm talking about line 30. At line 30, the compiler has a swap values function, but it takes two integer references because that function is produced already. But it doesn't work with the character, so I am going to produce another function. I am going to write another function, overload the swap values with two character references. Okay, and it calls the it produces code to call that function, and it ends. When the compiler ends at line 34, okay, it produces three functions. One is a main function, the other one is swap values with two integer references, the other one is swap values with two character references. When the compiler is done, your program is linked, and when you are running, your running code doesn't know that its functions are produced by template instantiation. So for your running code, doesn't matter if you wrote it by your hand or you instantiated it, okay? Its efficiency is the same thing. It is memory usage is the same thing. As I said, during the runtime, there is nothing that indicates that your functions are produced by a template instantiation. Why do I keep saying this runtime compile time thing? Because people are confused about it. Even the authors of this slides are confused about it too. Only one question.
So we can use this templates mechanism for differentiate which type is used instead of using virtual polymorphism.
Polymorphism and templates are completely different things. Polymorphism definitely happens during the runtime. Okay, your code itself inspects the object to determine its type. Okay, and according to its type, okay, it gets the v table of it, virtual function table, and calls the right function.
I'm saying we don't have to. Hence, we have templates.
You can't do with the templates. There is nothing about runtime thing. Okay.
Yes.
So you cannot replace polymorphism with template instantiation.
I'm not replacing. I'm just proposing to use templates instead of defining virtual functions.
No, that's what I'm saying. Virtual functions are decided during the runtime, depending on the object type. Remember what we said about a vector of shape pointers? We don't know what kind of shape pointers I am getting, right?
But we can know with templates, right?
What?
We can know which kind of class we call.
Well, it's a shape class, but any class derived from shape could be in that vector. And I cannot know during the compile time what kind of shape I am getting. This one is not like that, okay? This one definitely, okay, says that when I do this integer and integer. Let's say this is a shape pointer and shape pointer, right? Shape pointer and shape pointer. I am sending two shape pointers in there, okay?
No, it will be either triangle or square, for example.
Well, if you send two triangles,
one triangle, one square,
okay, then it doesn't work.
Why?
Why? Because this one says that both of them has to be the same type.
Oh, okay.
It has to be, if t is an integer, both of them should be integer. If t is a rectangle, then both of them has to be a rectangle. Okay? So it will be instantiated for rectangles and that kind of stuff. Unless if this operator is an polymorphic operator. If that's the polymorphic operator, then templates and polymorphism can work together, but they are not replacement for each other. Okay? Yes?
What if I have a function that is useful for
then you don't instantiate it. Well, this is C, right? It is very easy to do harmful code. I mean, if it doesn't work for, well, we are going to talk about it in a few minutes. Well, while you are at it, maybe I shouldn't wait for a few minutes. But let me write the code. You are asking me to do this. Okay. Let's say I have an integer array. This is 10 and array 2, and this is 10 again, 20, whatever they are. Can I call this one on this array and array 2? Well, why not? I mean, if I can call it on integers, and if I call it on that kind of thing. But the thing is that array, what is the type of ARR? ARR is a integer pointer. Well, I can make this an integer pointer too, right? But they are constant integer pointers, right? You cannot change their values. I cannot make any assignment to ARR or ARR2. So in this case, when you call this line 35, you are going to get what? Crash or compiler error?
Compiler error.
Exactly. Why?
Because they are constant. Template compile.
Because templates are compiled type things, right? You don't wait until the runtime to make your decision. No, you can't. Okay. At line 35, templates are instantiated during the compile time, and this guy is asking to be passed as a reference, okay, non-const reference to a function, but ARR is a constant integer pointer, right? You can't change it. Okay, to be able to work for it, then I need to put a const in there and const in there too. But in this case, this line will not work, right? And this line will not work. Okay, so your answer to your question: when you write a template, okay, we are writing generic code. Yeah, that's right. But sometimes you cannot get as generic as you like, right? Sometimes your templates cannot work for some of the types. Yeah, it has limitations. Okay.
I was thinking that if I have a square root function and stuff inside of that function that I write.
If you have another function inside this template definition,
Yes.
well, you already have it. This is a function, right?
Yeah, but if I use square root function, then it won't be work for chars and other things.
Yeah, that's exactly what I am saying. I mean, in that case, the swap values will not work for some types. It will work for some other types. As I said, I mean, this is exactly what we are talking about. Const and const. I can write this function if I like, but this one will not work here, right? Because this is not valid for constant variables. But this will work, right? So again, even though, I mean, our main purpose, maybe the ultimate goal is to write generic functions, only the algorithm side. Well, sometimes it will not work for some of the types, right? Yes.
Can we define two different templates with difference to class type and then use two different templates?
Well, the thing is this. What did I say? The compiler would not produce any code for this piece of code. It produces code when it sees this line. Okay. So whatever you are doing when you call that template, instantiate that template, if that thing turns out to be a nice function without any conflicting overloading rules and etc., it is possible, yes. I mean, if it produces a function whose signature is the same as a function that was produced before, then you are in trouble, right?
So we can do polymorphism.
So come on. Okay, so polymorphism is your new keyword right now. Okay. Yeah. Yes, you can do polymorph. What is this? This is a reference, right? When you say variable one dot f, okay, one. If if f1 is a polymorphic function defined at a base class of some class hierarchy, since variable 1 is a reference, then f1 is a polymorphic call when it produces the call, okay? But it doesn't have to be. The template doesn't care about if it is calling a polymorphic call or if it is making a polymorphic call or not. Just produces the code, okay? Depends on what kind of variable t is. Obviously, this will not work for the integer class or the double class. It's a very specific code that is written for a class type, and if f1 is defined as a virtual function, then this is definitely f1 is a polymorphic call. Yeah. Templates are like monkeys, right? Okay. They are like monkeys. You give them this code, okay? They do this. You give them this code, then you say that Control H, then replace, find and replace. Where is my find and replace? Find and replace did not search. Oh, okay. Replace. Okay. It is replace. I'm going to replace it, and I am going to replace all the t's with integers, and only in this select it only. Okay. See, how come this one didn't work? T's. This one worked, right? Let me do it. I think I didn't select the.
It's only replace after cursor.
Because I selected the whole words only, right? Okay, so I am going to do this. Search, replace, select it only, replace t's with integers, and whole. Why doesn't it work? Whole words, not whole words only. Replace all of them.
Replace one.
Replace. Oh, replace again. Replace again. Yeah. Okay. So think about templates as like monkeys doing this search and replace. Well, I'm not a good monkey, I guess, because I couldn't do it. That's what you do. So you select the text, you replace all those things with an integer, and that's it. Don't try to make this into something that it is not. This is very simple idea. You just define an algorithm independent of the type. Then whenever you see such a thing, the compiler says that do I have a swap values with two integer references? No. Can I instantiate it? Yeah. Then call the template monkey, give the t and this integer, and it's going to do this replacement. Yeah.
You said
See, you had a question. When I asked you a question, did you have a question? You said no, but now you have a question.
this time I don't have a question, but in the process,
No, don't make excuses. So you have a question.
you said triangle and
Professors always know the truth.
triangle and shape. If you give the function, it gives to error to me because of this is not a same type.
You mean let's fix it. Yeah, this has to be the same type, right?
Shape and triangle is polymorphic classes, and
Well, I mean, this one says that no, you are not. They are not. We don't call them polymorphic. You are saying that there is a relationship between them. That's what you are saying, right?
yes.
But it doesn't. Templates are monkeys. They don't know about that. Okay, they are monkeys. If you like to use it that way, class S, okay, and this is S. Now I have this thing. Okay, now I have this thing. Well, can I compare it with a rectangle and triangle? No. Why? Because rectangles and triangles are not assignable. They are siblings, right? Well, can I use the is a relationship? One of them is a shape, the other one is a rectangle. Let's say shapes are not abstract classes. Well, since this is a relation, one way assignment will work, but the other way will not work, right? Because this one says that I'm going to assign it to that one and back to that one. Okay? Good. Okay. Those are good questions. Any other questions? Any other questions? So in order for this template to work, whatever I am sending, whatever I am instantiating the template with, it has to have the minimum of this assignment operator. If the assignment operator is not defined for that, if the assignment operator is not defined for that class, then this code will break. It will not work. It will not work. Question for you. What happens if I do this? Would my code here, would my code compile, and if it compiles, will it run? So I have two, I'm calling this code with two integer references and two character references, and my definition is like that. Okay, would this compile? Yes, of course. Why? Because I am instantiating it, and since this temp is a integer, in the first instantiation it was integer by coincidence. It will work for the characters. I can, if I like, I can assign a character to an integer. This part I might have a problem. I might get a warning when I compile it. I might get a warning, but well, it's going to work for this case because I know that I have only a number between 0 to 255 and this integer. Okay, it will work. But if I call this swap values with two doubles, okay, with two doubles, again I am assigning an integer to a double to an integer. Definitely I will get some warnings, at least some warnings. If I call the swap values with day of year, would this compile? Day of year objects? If I call this swap values function like this, it's an integer template, temporary. Day of year, yeah.
Special assignment operator.
If you have a special assignment operator that takes an integer, yeah, it could. Well, in fact, we have, right? Do we have it? Because, oh, you mean this, yeah, right? Yeah. Well, this might work because remember, it had a conversion constructor, right? That converts from a single integer, I guess, from a month. But this one will not work because there is no such assignment operator that will take a day of year and assign it to an integer. So it will not work for this function. What I'm trying to say here is that writing templates is not that easy, because if you make this mistake here, your template might seem like it is working since it worked for the characters and integers, and sometimes maybe for the doubles. Even worse, for a limited range of double values, it might work maybe. Okay, but later it's going to fail for other types. So be careful about those. So what do I have in there? I think I talked about the code. Let's go back to the slides and let's talk about what I had skipped. Function templates versus the overloading, they are very, very related, because each function instantiation after the first instantiation makes an overloading, right? You overload the swap values with the characters. You overload with the swap values with the doubles and etc. Okay. So we talked about this one. Again, this line is just, you just memorize it. Template is a C++ keyword. It's a keyword C. This one is a keyword, and you are saying the compiler that now I'm writing a template function. Okay, so you are not going to produce any code for this one. Let me go to my favorite website. Okay, no, not this one. This one is good, but this one is better. Okay, let's get rid of this one and let's Control V. Okay. What did it do? It is calling this one. Yeah. Okay. So this is our main function. What am I producing? Okay, Intel code. Good. This is my main function. Okay. This main function, why don't I get rid of these printout statements so that they don't produce extra code? All I have is two integer definitions and two swap value calls. Okay, see, I have 1 and 2. These are stored in this stack position, RBP minus 4 and RBP minus 8, 4 bytes each. Okay, I load them some special registers, and I call this, let me make this a little bit bigger. Okay, I call this swap values. What does it say? Swap values I, E, V, R, T, S1. And this is the function that takes two integer references. The second one is this. Okay, 65 and 66 are ASCII codes for symbol character A and B. Now I am calling to swap values function with two character references. IC, see, this is ICEVRT, this is IIEVRT. One is a character, the other one is an integer. So the rest of the letters, they just belong to being references and that kind of stuff. So this is the one for the integer swap function, and this is the one for character swap function. And if I write double A and B, okay, and swap is V big, okay, values A comma B, A comma B. As soon as I hit this one, now I will have the third one. See, this one is the double. One function for the integers, the other function for the characters, the other function for the doubles. Their code is very different, right? Their code is very different. It has to be different because they work for different kind of classes.
So virtual function is unnecessary.
What?
Virtual functions.
No. How many times I should say no? But this guy is
Compiled for different prototype.
Different.
using templates. Okay, is not a replacement for polymorphism. You need the flexibility of polymorphism. Okay, for many cases, templates is not replacement for polymorphism. Okay, because you need to make your decision during the compile time for templates. We don't like polymorphism because it is slow. We like it because it is flexible. Okay, why? Because things are decided during the runtime. That's what I'm saying. It doesn't. No, he's making on this purpose, just trying to throw me off. Okay, any other questions? Good. Okay, so let's go back to the slides again. I did that. Okay, so template prefix is okay. Instead of class, actually, they suggest that there is another keyword in C++. It is type name. They say that, well, I mean, using the keyword class here is not that meaningful because class means that I am defining a new class, that kind of stuff. Use type name instead of class. So that's a more meaningful that's a more meaningful employment of this keyword type name instead of class. But people don't listen to this suggestion, including me. We keep writing class. So if you see somewhere instead of class, if you see this type name in here, okay, it is exactly the same thing, no difference. And this is the one that is correct. Okay, it's like saying charge Biz in Turkish bir şarj ederiz değil mi? Biz şarj ederiz ama doğrusu şarjdır. Değil mi? Ama biz şarj ederiz hep. That's something like that, okay? We know that it is wrong, but for some reason it is like everybody's using this class thing. That's what it says. Most use class anyways. Again, can be replaced by any type as long as that assignment operator is valid. Okay, good. By the way, I mean, I gave an example too. I mean, you don't have to use, of course, this T, but usually it's like for the indexes of the loops, we use IJK, right? We don't have to, but we use IJK because everybody knows that IJK means their indexes. Well, I mean, for template types, we usually use T, S, K, L, etc. We usually start with a T. Okay, this is a template type. We don't have to, but this kind of a tradition. So function template definition, swap values. Compiler only generates definitions when required. See this one? This one. Okay. If you don't make these calls, if you don't make any of these calls, okay, your main function is just this. That's it. There are no function definitions for swap values at all. Main doesn't do anything. And how about this function? I mean, don't I get any code generated for the swap values? No. As I said, no. For the compiler to generate some code out of the swap values, you need to call it. You need to call it like that. As soon as you call once, the code will be produced during the compile time, of course. Compiler only generates definitions when required. Okay. Only one definition. Okay. Okay, so you are not specifically saying that I am instantiating something. Okay, you are not specifically saying that, but you are just simply calling it. Could you wake them up? Just that one and the other one too. Yeah, this way. Okay, so another example. Show stuff. Okay, templated definition. You say that, well, it's like the regular function definition. I am going to define a template later. See, semicolon here. I can do that. Later you can give the definition. And this show stuff. See, this one say that show stuff will work like this. I need at least one integer and two T types. I don't know what the types of T are, okay? But I know this one is an integer, okay? If somebody calls this function with an integer and two T's, for example, two characters, the compiler generates some code. I definitely know that, okay, when I look at this code, I definitely know that this is an overload the stream insertion operator for the integers. I know the meaning of this one. I don't know the meaning of this one or this one when I read this template definition. The meanings of these two will become clear, okay, will become available when I call this function. And this kind of mix and match kind of template header definitions are possible. It is you can do that too. So you definitely know that this first one is going to be an integer. The rest of them could be integers or something else. Okay, so when you do that, it will be a double instantiation of this show stuff. Okay, good. By the way, you could do this. You can say that, okay, how does the compiler know that the swap values will be instantiated with one integer, right? Because it knows the type of the integer. But if I like to force my compiler to use the integer instantiation, I can do this. Okay? I am forcing the compiler to use int as the t type. Don't deduce it yourself. Okay? Don't find out the type yourself by looking at the integer definition. I am telling you that instantiate it with an integer. Okay? This is what I am saying. You can do this. What?
Is it useful in one case?
Well, so in this case, no. But sometimes they say, well, I mean, instantiate it with integer, but I am going to send you a character. You could say that. Okay? Sometimes, well, how about this? Can I do this? If I do this unsigned thing, unsigned. If I have an unsigned integer, two integers, unsigned integers, okay? Can I instantiate it with an integer and it work? Let me try to compile it. You understand what I'm trying to do? Say yes. No? Ask him during the break. Okay. Well, it does not. What does it say? It says, no matching functions call to swap values unsigned integer, yeah. It didn't take it. That reference is messing things up. If it is not a reference, then let's make something crazy, like this one and this one. I think this will work. Compile. Well, of course, it is not. It beats the purpose of this thing. Yeah, of course. Yeah, it works. Yeah. So, even though integers are unsigned integers, I made it work with integers. Okay. Unsigned integer and integer are two different things. One of them doesn't know how to represent minus signs. That's why it starts with a. So, I'm saying that for the purpose of this function, it's going to work with the unsigned integers. Okay. So I force it to use, and what does that mean? It means that I am not going to produce separate functions for integers and unsigned integers. Okay. It's going to be the same integer, so it is flexible enough.
It's not compiled because we forced reference to be normal.
But it didn't work. I tried it. It didn't work because I cannot use a integer reference for an unsigned integer reference. They are two different things. It's like pointers, right? Can I do this? Okay, good. Any questions? The last experiment was an important one. Try it yourself. Okay, if there are no questions, let's take some break.
Template yerine auto keyword kullansalar daha da syntax olarak basit olmaz mı?
Ne?
Syntax olarak daha sade olmaz mı? Auto yazsak template'in yerine.
Ama template olduğunu çok bilmiyorsun. Artı bir de hani orada ben T dedim ya mesela. Auto dediğin zaman ne yazacaksın buraya? Bu niye böyle yapıyor ya? Şuradan mı oynuyor? Şuradan mı oynuyor?
Aynen doğru diyorsunuz hocam.
Yok yazarsın bak şimdi auto dedim buraya. Auto dedin temp.
Ama
Bir dakika auto temp atama variable one dedim. Anladın mı?
Semantiğe bağlı.
Ya yok hayır. Auto temp atama variable 1 dedim. Oradan anlar bunu. Var bir yolu var ama flexible değil.
Nereden anlar dediniz?
Auto temp atama variable one. Şuraya öyle dedim.
13. satırda ama.
Bu niye titriyor ya?
Şu şarj şeyinden tutuyordum şimdi.
Onu takınca mı oldu? Vallahi ondan oluyor.
13. satırdan mı bilebilir diyorsunuz? Sen
9. satırdan bile. Şimdi 9. satırdan sen auto yazdın ya oralara. Auto deyince variable 1'in tipini anladı değil mi?
yani.
Anlayınca 11'e de onu yapabilir.
Ama onu nasıl anlayacak? Eğer
Kom-
auto dersek.
Auto zaten compile time'da çözülüyor.
Ama 11'e mesela auto temp dersek temp yerine o zaman bunu da ne bileyim integer ya da karakter yapacağını semantiğe bağlı bir şey. Değil mi? Biz
Auto
şimdi
temp atama variable bir diyeceğim zaten.
bunlara hepsine T dediğimiz için
Auto
hepsi aynı
temp
oluyor.
atama variable diyeceğim. 13 ile
Ne
11'i
diyeceğiz?
birleştireceğim yani.
Auto temp
Auto temp atama variable 1.
13'te 11'i birleştirirsek
Heh, tamam mı? O zaman. Tamam. Ama şey de var yani ne diyeyim. Template'ı tamamen otoyla değiştiremezsin. Class'lara falan geleceğiz, göreceğiz orada. Bu tamam mı? Tamam. Şuradan.
o force etme olayı olmaz ortada mesela.
Yeteri kadar flexible değil template arkadaşlar.
Kaç saat aradın geçiyor?
Denizin dibine iniş yapmayı beceriyorum. Sayılı az kaldı.
Evet, suya taş atsam.
Hareketli iniş yap.
Evet, suya taş atsam ama benim şey.
1 metre bölü saniyede
Geliyor deniz.
Gidiyor tamam mı? Talha Zeynep ben kalıyoruz ve tamamen stil yani.
Sen bir canım yok. İkimiz de kalmayacağız. İkimiz de illaki bir şey.
karşıya çıkıyor.
Çok yoğun oldu.
Yaşıyor değil mi?
Benim bacağım hocam hiç düşünmüyorum. Bence nefret sana. Bir şey topladım şurada.
Amerika'da yayınlanmış 20 yıl sonra. Tamam, neredeyse.
Yemiyor. Buna ferit bir şeylerden almam lazım. Aptal adamlar koymamışlar ya. Gözlük. Okay, so talked about this one. The thing is this. Remember, what we said before. We said that from the beginning, from last year, we said that swap the function definitions are usually done this way. Put a semicolon in there and copy the whole thing after the class definition, okay, and move it out. Okay, so something like that, right? So you are saying that I have a template definition like this. It's like a function definition, like a function header definition, and use it to instantiate this function here, and use it to instantiate this function call here, and the template definition will come later, right? That's how we did our functions, how we define our function, and it used to work fine, but unfortunately many compilers doesn't support this kind of template usage. Okay, I wonder if this one takes it. Let's try to compile it. Well, this one does it, yeah. This one does it correctly, but it doesn't have to. Well, it has to, but it doesn't sometimes. They say that whenever, well, did it compile? Did it compile? And let me see if it runs. ABBAI, it runs, yes, okay. So, whenever the compiler sees this line, it needs to know the full implementation of the template definition, because it's going to instantiate a new function, right? And whenever again it sees this line, it needs to see the full template definition, including the whole implementation. So usually we like this kind of program design. You define the function header or the template header before. Okay, this is what we like, but usually compilers are not okay. Many compilers are not sophisticated enough to support this kind of a usage. In my case, it was okay, but your compiler might. I mean, I'm not sure if GCC is supporting it that way. But it sometimes it doesn't. That's why the book says that okay, it is safest to place template function definition in file where it is invoked. So I remember the separation of the interface and the implementation. It is still valid. We still like it, but sometimes due to compiler complications, we can't achieve that nice property. Okay, separation of interface and the implementation. Okay, so depends on your compiler. That's why people play safe, and they place, unfortunately, they place all of their template definitions in the headers. That's what they do, including the implementation. Okay, including the implementation. If you look at the vector.h, remember vector is a templated class, you are going to see the whole implementation inside the header file. Okay, unfortunately it is. Let me try to find it. C++ vector h source code. Let's find it somewhere. Let's go there. Okay, this is the vector class. Okay, vector header. This one is okay, and namespace definition and namespace. Okay, the template definition here. Class vector. See templated class here. Vector. What? Well, it's a debug vector, but I mean I couldn't find other one. Do you see it? This one? Where did it go? Well, I mean just an idea. Okay, this is debug vector, but it's a vector class, and you are going to see that it's a very long file. It's a header file. Okay. The operator itself, the operator, the parentheses operator, and the swap thing. What is this? Operator greater than for some vector. See, it is all implemented in this class, in this header file. Remember what we said? We said that hide the implementation from the user. Don't show it. Your header file should have only the class interface itself. Because of this, the compiler complications, we usually include our whole implementation in our headers. Okay, we don't like it, but sometimes we have to do it. Well, I mean, it is something to make a mistake. Okay, that's a bad thing to make a mistake. Yes, that's true. It is the other thing that I had to do this. I know it's a mistake, but I had to do this because of this and this. Okay, I know what I am doing. It is bad. I take a note of it. I am doing it because of this problem. Okay, it is a little. It makes it a little bit better than making a mistake without knowing it. Okay. So let's move on. Multiple type parameters are possible. Class T1 and class T2. Okay. The book says it is not typical. Again, this is wrong. We use it in many cases. It is typical, yes. Okay. We use class templates with many type parameters like these. Okay. And by the way, you cannot say that I am not going to use this. I am not going to use this template T2. Well, I can remember. I can define functions with unused parameters, but with the templates you can't. By the way, most people ask me about this question. Can I make it like this? What does this mean? Can I write it? A default template parameter?
I think yes.
How am I gonna work? How am I gonna work this? If I don't specify an integer, you are going to assume that it's an integer. How are you gonna call the swap values without specifying an integer?
Keys will be replaced as an integer.
For anything, then in that case, why don't you write a two integer thing, right? I mean, when you say swap values, it already knows that you are going to call it with two integers. What is this integer doing here?
Not meaningful.
Not meaningful for functions, but for classes it is, yeah. Not meaningful, may not be very meaningful for the functions, but it is meaningful for the classes. Okay, when we see the class templates, you are going to see that it is meaningful. And other things are like this. Integer k, what does that mean? Well, why would I take an integer? I mean, if it's an integer, then it's going to be a parameter for the function itself. Well, we are going to see this, okay? So templates are very, I mean, you can use templates in a very different ways, and it's a sophisticated mechanism. When I say it's a monkey, right? Well, it is not a very simple monkey. It's a complicated monkey. It knows lots of stuff too. I am not covering everything about templates, but I'm going to show you a few tricks about templates that's very unique to C++, and you can do stuff regarding both reusability, algorithm abstraction, and at the same time, I am paying attention to efficiency too. Maybe one example somewhere where I can do. Okay, when the time comes, I'm going to show you. Okay, so this is not typical, no, it is typical. You can have many template parameters. Algorithm abstraction is the thing that we are after, okay? We provide an abstract algorithm without paying much attention to the types of the algorithm. I am just going to give you a sorting algorithm. I don't care if it is sorting sorting an array of day of year objects, or the vector objects, or the integer objects. Quick sort works this way. Or remember the binary search? Remember the binary search example that I gave you about integer binary search, right? But it works for anything, okay? It works for anything. All you do is you make a copy of your binary search and you replace all those integers with day of years, and it works, and etc. Templates say that, okay, I'm going to do it myself.
Can I ask a question?
Yeah.
Why don't we have used templates instead of all types?
All types?
Yes.
Well, if you don't have to use it, why are you? I mean,
It's compiled time.
let's take the function square, right? Function square, okay, or square root. In math.h, square root works for doubles. Do I need to instantiate the square root for characters or day of year? No, right? Square root works for doubles only. Why make it more complicated than it needs to be? Well, most of the time we know what kind of specific function it's going to be, so don't make it more complicated. But I agree with you that try to write your functions in a most generic way because it is usable. Yeah, if you can do it that way, yes. But I mean, what is the point of making your main function a templated function? There will be only one main function, and it is going to return an integer. It will take two parameters, and that will be it.
I'm anticipating a language most like easy to use, like JavaScript, no type
Or Python, right?
influence,
Yeah.
but also compiled time language.
Well, if you
Templates.
if you like to use a compiled language because of its efficiency, then you have to accept some rules. I mean, they are not as flexible as Python, right? Because some of the decisions has to be made during the runtime. Runtime means that no code produced during the compile time. That means an interpreter. Java is trying to find the kind of in between. We'll talk about it. Well, people, I mean, I am not saying that no, it is not possible. Well, it's definitely a trade-off. But C and C++ is at very, very compiler end of the spectrum. Okay, they say that we are compiled, and I'm going to tell you most of the compilation rules. Okay, so if you are smart enough, you are going to produce very efficient code, but it's going to take you some time to write that code. Okay, so algorithm abstraction is something that we are after with the templates. Write your code in a most generic way. Remember what we said about the polymorphism? Polymorphism is trying to do the same thing too. Write your code in the most generic sense. Okay, I'm going to help you to find the meaning of this code during the runtime. That's what polymorphism says. Templates say the same thing. They say that, okay, write your code in the most generic case. I am going to produce you code that will be instantiated correctly, okay? And the nice thing is your runtime will not get affected from this instantiation. It will run as efficiently as your own code.
Are there any language have template mechanism other than C++?
I am not sure. No, I am not sure. No. Well, in C you can. Well, this is how you do the C templates, right? When you take the square root, remember the macros? Macros are kind of templates, right? When you say square x, okay, oh, I didn't write it correctly here, maybe write it right. Okay, so define square x by do what? X, okay, x times x. Okay, so this is your square x, and it will work for all kind of variables, right? Integers, doubles, characters, and everything. This is a much less complicated monkey than templates, but I mean in C, poor man's templates are macros. I can do that, and in fact, I can do this. What am I gonna do? I would say, yeah, I will say this: square an integer, okay, or x, yeah. Let me do it this way: x. I am writing a function. When I see this square x, I am writing a function. It will return an x, and it will say f square x. It will take an x parameter, and it will backslash return x times x backslash and this. So whenever I say square int or square double or square character, it will produce some code here and it will compile it, right? So instantiation is not automatic. I have to instantiate it myself, but it works. And you're not going to get much help when you debug this stuff, but it works. So back to your question, I mean in C, well, there is nothing you can't do in C. There is always doing things in C, but it will cost you. I mean the syntax is bad and it's difficult to understand, that kind of stuff. Other than that, I am in Java. Java says that we don't need kind of, if you're going to write some generic code, then write your code as abstract as possible and use polymorphism. But Java says.
Is template mechanism cause any decrease in debugging?
What?
Like macros you mentioned?
Yeah. Well, I mean, if something goes wrong with the macros, since macros are not compile time things, they are their preprocessor, then the compiler doesn't know what you're doing with so that's going to be a tough thing.
But in templates, no such a.
Well, templates, it is not easy to debug templates either, because when you get an error message, for example, let me fix this. Let's fix this. Get rid of that one. Yeah, here it is. This one compiles, right? Let me get rid of this one. Yeah, okay. Does it compile? Compile. Okay, if I take this one out, and if I take this one out too, still compiles. No problem. And here I could say temp dot f1. Okay, will I get a compiler error here? Okay, let's compile it. Okay, no compiler errors. Okay, how come I didn't get a compiler error? Because I don't know what this f1 is. Well, the compiler doesn't say that you didn't instantiate this function yet. Okay, when you instantiate it, I would know that if temp as an f1 or not. As soon as I instantiate this, I will get a error saying that, okay, I have a problem in here, but that problem comes okay, from this call, not the template itself. Okay, so when you try to instantiate it with an integer, okay, you will produce an error message. What I'm saying is that your template code would produce different error messages for different instantiations. Okay, so depending on how you instantiate it, you are going to get a different error for the same line, so for the same piece of code. That's why they are not as easy as writing concrete functions, not abstract functions, but concrete functions. But of course, they are much better than macros. Okay, algorithm abstraction, we talk about it. So how do we write templates? This is how you write the templates. You write your template as a regular function, for example, for that swap values. Write it for the integer class, integer variable, and copy and paste it, and change all the integers to doubles. Does it work for both of them? Yes, and that means that I can replace all of those integers or doubles with a generic template type T. So write it for a normal function, then convert it to a template. Because as I said, compiling a template by itself will not produce any code. You will not get any error message. Okay. Good. Okay, inappropriate types in templates, we talk about this. Okay, this is exactly the same code that I showed you. Okay, so it takes two integer constant integer pointers. Swap values will not work because they are constant. They cannot be non-constant references. So you cannot. That's what I'm saying. You cannot instantiate templates with any type that you like.
So it seems it has not so much of an issue of debugging, unless we don't call it.
Well, I mean, we are human beings and we are going to make mistakes, right? I mean, there will be time to debug these templates. Templates are not as easy debug to as the regular functions. That's what I'm saying. Okay, you might say that, well, it works for the doubles, it works for the integers. I mean, there is no guarantee that it's going to work for the day of year classes, right? You might get a surprise compiler error when you instantiate it with the day of year class. Okay, so class templates, before starting class templates, maybe go back to the loop, go back to the book, and the book has, okay, the book has this sort template defined for us. It's going to take a array of t's, generic sort class, and this one says that I'm going to take an integer, okay, number used. It's an array, but array of size, number used. It's nice. Okay, good. And then what? And then I am going to, well, swap values is already there, right? Swap values. I am going to swap the values of those two. Another one is index of smallest, another template. It takes a constant array, right? Constant array. I am not going to modify it. Start index and number used. It says that out of this array, starting from start index, I am going to find the smallest value, and I'm going to return it to you. Okay, and it will be done that way. So see this one, sort.cpp is included. It's a bad thing, but sometimes we need to do it. Why are we doing it? Can I open this sort.cpp? Can I see it somewhere? It is okay. No. Where is my CPP file? Okay, Savage. Source code, chapter number 16. Yeah, sort.cpp is here. Inside this file, I have all the implementations of sort, swap values, index of smallest, and etc. I have to do this because of, as I said, you need to put everything, all the implementation in your header file. In this case, I didn't put them in my header file, but I put them in my CPP file, and I'm including that CPP file, which is a bad thing, but I have to do it because of the compilers are missing stuff. So swap values are there, no problem, it is the same thing. Let's look at this index of smallest. Why don't we go back to this one? Why don't we go back to this one? Why don't we go back to this one? Yeah, and look at this sort, the main function that calls the sort. I have an index integer array of size 10. Okay, I print the values out, and I sort this A, and I print the values out. I expect that it's going to be sorted. And then I have this double array. I print them out. I call this sort, and it will be done. Then what? I have an array of characters, and I will sort it with the sort function. It will be sorted. So the same generic code sort is used for the three different arrays. Okay, double arrays, integer arrays, and character arrays. Nice. Okay, so this is as easy as just calling the sort with a new type and an integer. Integer is always there, right? Integer always there. Let's look at the sort CPP. Okay, let's look at this index of smallest template. Again, these are integers. These are not t's, right? These are integers. Why? Because whatever the type of t is, doesn't matter. Double, character, day of year, or vector. These will be start index and number used. And it is very, so what does it say? It says that my minimum at the beginning is a start index. Beginning of the array, this is my minimum at the beginning. And index of minimum is the start index. I am going to scan my array starting from start index plus 1 to number used. And I'm going to make this comparison. If a index is smaller than minimum, okay, I do this assignment. And at the end, after this for loop, I return the index of the minimum. So for this index of smallest to work, okay, for this index of smallest to work, what kind of functions What kind of functions have to be defined on that class? First, assignment operator has to be there, right? Assignment operator for this T type. Also, the less than operator has to be defined, right? What else? Do I have anything else other than these two operators?
So what is the question? What is the question?
For this function to work, to be instantiated, it looks like I have this assignment operator has to be there. If t is an integer, then assignment operator has to work on the integers. Also the less than operator, right? Do I need anything else, any other functions for this class to work? Yes.
Index.
A index. Yeah. Well, index is, do I need that index? What is the index operator for an integer? Well, remember, A is not a integer, right? A is an integer pointer. So A is a T pointer. For the pointers, index is always defined. But that's a good point. So you are saying that for the pointer of that class, index has to be there. That's what else? What else? There is something very, very important. This class T has to have something.
Smaller than.
What?
Smaller than.
Yeah, that's what I said. Smaller than operator, assignment operator, okay, and one more thing which is very important. Well, this one is already an integer, right? I'm not talking about this. This one is already an integer. These are all integers. Smaller than, yes. Index for the pointer of that class, yes. Assignment we talk about it. This is an integer assignment. Okay, and this is I am returning an integer here. Okay, no problems. Very important, yes.
Destructor maybe.
What?
Destructor.
Well, destruct. Why? Because you are making a new object from this. Yeah, maybe. But before that, yeah, you are very close. Before that, before the destructor, this class should have a copy constructor for line 30 for this one, right? This is not an assignment, right? This is a copy constructor statement. This class should have a copy constructor. Otherwise, this line will not work. Okay? Good. So, as I said, writing a specific function, non-templated function, is easier compared to templates because I don't need to think these kind of stuff, because when I compile it, if it is not there, then I get a compiler error. As I said, you don't get any errors when you compile a template. You get a compiler error when you instantiate it. And you don't know what kind of instantiations your customer will do, right? You don't know what kind of instantiations they will do. Okay? If your customer instantiates this code with doubles and integers, it will work. But if your customer instantiates your code with a class with no copy constructor deleted, then you are in trouble. So maybe the better thing for a compiler, for a template class, template function should be this. Okay, this one says that okay, it is okay to have a no parameter constructor and assignment operator for that class. Now I am not using the copy constructor of that class, right? So what is the difference between this line and this line? Okay, one requires copy constructor, the other one doesn't. Okay, so let's move on. This is the index of smallest, returns the smallest one. Did you understand the algorithm of this sort? I think it is going to pick the index of the smallest of the whole array. So it's going to swap whatever the smallest is in my array with the first element. Then it's going to pick the index of smallest of the rest of the array, then swap it. Understand? So that's going to be like this. Okay, choose the index of smallest. Let's say it is this one. Then swap this one with this one. Now I have a new problem. New problem is this. I have an array of size n-1 and choose the index of smallest out of this array. Let's say it is this one. Then replace this one with this one. Then continue this way. Every time decrease the number of elements in your array by 1. Okay, and keep doing this. That's what I'm going to do. And this is the sort function itself. Sort says that integer index of smallest from 0 to number used -1. Find the index of smallest starting from index number used. Okay, and swap the indexed element of A with the index of smallest, and keep doing this until your index becomes the number used -1. This is the algorithm, generic algorithm. For this function to work, what kind of T classes can I use? Can you tell me? What should work for T? Okay. Do I need the assignment in this one? I don't use the assignment, right? Assignment is used by the index of smallest, but not for this one. By the way, when you call sort with a double array, when this function is instantiated, this function has to instantiate index of smallest. And index of smallest instantiate swap values if they are not there, right? So this is a very generic function sort, and it will work all types of objects as long as index of smallest and swap values are defined, can be defined on those. And it is nice that, see, this is not a constant array, but index of smallest is constant. Why? Because I am not changing anything, right? I am not changing anything. Okay, good. Any questions on this sort example? C++ templates library, there is a STL, remember, standard template library, includes functions like these, sort function, and let's go to that one. Let me go to my second or third most favorite website, STL sort function. If it works, I am going to get it. Okay, here it is. Okay, how am I gonna, where is this, where is the search? Do you guys see search somewhere? Source history? What? At the top? This is create account. Oh, this is search. Ah, okay, okay, good. STL sort. There is a function called sort somewhere in the standard template library. Okay. This one. Well, I guess this one uses lots of iterators. I didn't talk about the iterators yet. Okay, but it doesn't hurt. Okay, I have an std array. See this one? Array is like a vector, but it takes this one. What is this?
Sorry.
What do you think? What do you think this one is? But it's a template, right? Why would I give the number of elements to template? You already know the number of elements by counting this, right? I mean, the meaning of the vector, why did we like the vectors? If they are dynamic, right? So why are we giving the number of elements to a vector? What?
Initial size.
Initial size, but why it is not a parameter to the constructor itself? It's a template parameter.
Because compiler needs to Size of array.
How come it didn't know? How come it didn't need to know when we write the PFRAD? Remember when we write the PFRAD, we gave the initial size as a parameter to the constructor.
But
Right.
we had capacity at PFRAD.
Yeah, well, why don't we do the same thing with the array? So the parameter to the template is different than parameter to the constructor. Okay, this is a much more abstract parameter than the constructor parameters, like the integers. Why are we giving this 10? Well, everybody is correct. Everybody said that this is the initial size, right? Why are we giving this initial size parameter to the template instead of the constructor? Well, if I give this template parameter to the constructor, I can allocate that kind of space like we did with the PFRAD initial size, right? I didn't have to use all of it. But this one says that no, don't do that. Okay. Make this part of the template. What does that mean? Okay, I mean, you think about this problem. We'll talk about that maybe tomorrow. So this sorting works from beginning to the end. S is an array. Begin means, okay, it's an iterator thing, but think this as like the first element of the array and the last element. Sort them, sort this array between these two. And sort is a generic function. Of course, it's a templated, and it works. It works. And in fact, see this one? Nice, right? I am going to use the greater than operator to compare the elements. If I like to sort my array in increasing order or decreasing order, okay, I can change it. Another parameter to the. So is this a parameter to the template sort or the parameter to the sort function?
Sort function.
Sort function, right? Not the template. Template parameters are there. So think about this one. I think I am out of time for today. Tomorrow we will discuss about that. Check this documentation out, the sort algorithm of the STL library.
Hocam template'ları böyle köşeli büyüktür küçüktürün arasına yazıyoruz ya.
Evet.
Başına